Falcons? Mr. Mac here, Earth Science. We're talking about Newton's laws. I got the alien Easter egg spaceship Lego here. And I'm going to drop this from the balcony in my house. I got David on video. I got Cassie on slow-mo. Jovi on slow-mo. Bryce is over there in the hall doing his video. Adele's watching. We got the whole crew here. Special edition Easter egg drop Lego. Now I'm going to drop this, and I want you to think about Newton's 3 laws. I want you to think about what 3 laws are present in this situation. And those are going to be your video notes. So 3 things, Newton's laws, how does it apply here, and then 2 other interesting things. Here we go. 3, 2, 1, dropping the egg. All right, what's going on, Earth Science? I hope you enjoyed that Lego Easter egg drop. Now, right here we have really nice simplified versions of Newton's laws of motion. Number 1, if an object is not moving, it will not start moving by itself. If an object is moving, it will not stop or change direction unless something pushes it. Second law, an object will move further and faster when they are pushed harder. And third law, when an object is pushed in one direction, there is always a resistance of the same size in the opposite direction. So again, with the Easter egg drop, you're thinking about those 3 laws of motion and how Newton's laws applied to that Lego Easter egg drop. Just thought I'd briefly go through each law here with you real quick. So Newton's first law, every object persists in a state of rest or uniform motion in a straight line unless it's compelled to change that state by forces impressed on it. You know, like I said before, basically an object is going to stay in motion or it's going to stay at rest until some sort of force changes that. So if something's at rest and you push it, it's now in motion. If something's in motion and it hits something, it's no longer in motion. So that's kind of Newton's first law there. All right, let's take a second here to talk about Newton's second law. Newton's second law talks about how objects will move further and faster when there's a force applied to it. So you have force equals mass times acceleration. And that right there is Newton's second law. So you have some graphics there and some of the equations there that talk about how Newton's second law works. So you think about adding a force. So if you have an airplane moving at a certain speed, and then they turn on their afterburners or they apply more force, you're going to see that aircraft accelerate. All right, so lastly, we have Newton's third law of motion. And this kind of is like friction. You know, for every action, there's an equal and opposite reaction. So you think when an object's being pushed in one direction, you're going to have resistance coming in from the other direction of the same size. So as you're pushing an object, you have the ground or the air that's applying friction. Well, if you apply more force, then it might start to move, but that other force is going to be trying to push against you to stop you or slow you down, that reaction. So again, for every action, there is an equal and opposite reaction. All right, so just to recap Newton's laws of motion, if an object is not moving, it will not start moving by itself. If an object is moving, it will not stop or change direction unless something pushes it. Newton's second law, objects will move further and faster when they're pushed harder. And then the third law, when an object is pushed in one direction, there's always a resistance of the same size in the opposite direction. So for this week, I want you to think about, again, the Lego Easter egg and how it fell, it hit the tile, and then it shattered. And I want you to think about how Newton's 3 laws of motion applied to this example. So you're writing 3 things down, Newton's 1, 2, and 3 laws, and then maybe 2 other things that you may have learned from this week's Mac video. Hope you all have a great week.